Welcome to this video on improving your decision tree-based strategy. Have you ever looked at your own vehicle and thought about changing a few parts to extract maximum performance from it? Maybe you could add new tires or an engine. In a similar manner, you can think of an ML model having the following components: input data, ML model, output, and the options trading strategy. What if you could modify the components to increase your strategy performance? If you look at the input data, you can think of feature extraction and pre-processing to improve the data. While you were using a decision tree model in the previous sections, maybe you can use a logistic regression model. When it comes to output, instead of forecasting the future's prices, you could forecast implied volatility. And when it comes to the options strategy, you can use a naked call or a protective put strategy. This can be an entire topic in itself, but let us focus on the ML model right now. You can choose any ML model, but since you built a decision tree model in the previous section, let us see how you can improve the decision tree. You give two inputs to the ML model: the input data, as well as certain parameters such as the number of estimators and maximum depth. These are the hyperparameters, which were chosen manually. Now, you could improve the ML model by optimizing these parameters with a process called hyperparameter tuning. Further, a decision tree usually gives the output as 1 or 0. But it can also give the probability of the output being 1 or 0. The higher the probability of an occurrence, the better our chance of being right. Thus, you can use a higher probability threshold for the decision tree to give a particular output. So far, you have looked at improving the decision tree model. What if you could use multiple decision trees and then aggregate the results to provide one output? This can be done by using a random forest model, which is an ensemble model. But why should you restrict yourself to one type of ML model? You could also use multiple ML models, like logistic regression, XGBoost, and decision trees together. And then use a voting method to identify and give the best output. This is the voting classifier method. In the previous method, you used a voting mechanism to give the output. You could add a machine learning model instead, which takes the predictions of the ML models as input and after training, gives the predicted output. This is the blending and stacking method.